Beran Instruments Limited of Torrington, UK is a long-established supplier of vibration condition monitoring and transducer calibration systems. The company was established in 1984 and operates out of modern and recently expanded premises with sales and support offices worldwide. Beran Instruments is ISO 9001 approved and ensures a rigorous quality system is in place for all stages of the design and manufacturing process. The company has developed the TransCal system for the power and process industry. It allows dynamic sensors such as accelerometers, velocity and proximity probes to be calibrated both as separate devices and as part of the entire measurement system. Historically, vibration transducers have been calibrated at one frequency, such as 50 or 60 Hz. This used to be perfectly adequate because it was the predominant vibration frequency of interest. With the advent of modern condition monitoring systems, the performance of the vibration transducers and their associated integration and filtering electronics is critical. Condition monitoring systems decode the overall signal level into individual harmonics, phase relative to the once per revolution marker, and also display the amplitude of any individual harmonic components, often up to frequencies as high as 10 kHz in the case of pump and gearbox monitoring. So the historic single frequency sensor calibration at 50 or 60 Hz will only test a fraction of the range over which the transducer is now being used. Having made a large investment in condition monitoring equipment, it makes sense to ensure that the benefits of this investment are not jeopardized by faulty transducers. This is becoming increasingly important as condition monitoring is used to extend the periods between maintenance and to help maintenance personnel pinpoint the cause of change in vibration. Traditional manual calibration methods are time-consuming and require a number of separate components to be assembled. The process involves mechanically mounting the test sensor on top of a known reference sensor and manually setting a number of known frequencies and amplitudes on the signal generator. With the switch set to ref, the amplitude level is manually tuned at each frequency, and once stable, the switch is set to test and the unknown device measured. This is repeated until the complete frequency range is covered, with the full calibration typically taking 30 to 40 minutes, including manually documenting the results. The Beran TransCal system automates this whole process, reducing overall calibration time to just 3 minutes per sensor. The same shaker and traceable reference are used, but the individual components are replaced with a single measurement and control unit. The generation of each test frequency and amplitude is automated with a high-speed closed-loop control, and the reference and test sensor signals are now measured simultaneously. The measurement process includes a unique noise and harmonic distortion rejection technique to ensure high repeatability, allowing a rugged and low-cost shaker to be employed in a rigorous industrial environment. Normally, the technician takes the Beran TransCal system to each transducer location and connects the shaker and reference sensor to the main unit. Or alternatively, if all the sensors have been removed for an outage, they may be brought to the system based in a workshop. Accelerometers and velocity sensors are directly mounted onto the reference and connected to the TransCal system, while proximity probes use an additional fixture. The transducer type and serial number is selected from a database, and the calibration tests automatically run in sequence. On completion, the results can be printed into a user-defined certificate format or stored for batch plotting later. As well as separate transducers, The Transcal system allows any isolation amplifiers, integration stages, filters, trip alarms and control room displays to be traceably calibrated for each channel as a complete measurement chain. In this procedure, the transducer remains mounted on the shaker table, but it is reconnected to the plant instrumentation. A new calibration test is recalled from the database in order to calibrate the plant instrumentation in its normal operating vibration units, usually velocity or displacement. The test typically comprises of a number of step increases in vibration, and whilst running, a second technician monitors the readouts on the condition monitoring and plant protection systems to ensure that they're reading an identical vibration level to that being generated by the Transcal system. After the calibration test has been completed, the engineer may also check any chart recorders and other control room recording systems to ensure correlation with the same vibration step levels that were provided by the Transcal system. In this way, the complete vibration measuring chain has been calibrated. This ensures that accurate machine condition is established from verified sensors and instrumentation at a range of vibration levels and frequencies. With the Transcal, the vast majority of the calibration is achieved automatically. The only procedures that have to be performed manually are initially mounting the transducer and visually monitoring any analog display on the protection rack, condition monitoring system and control room consoles. Using the Beran Transcal ensures a high confidence when reaching decisions to extend the periods between maintenance or assisting maintenance personnel to pinpoint the cause of change in vibration. There's more information about the Beran Transcal system on our website at www.beran.co.uk. You'll also find contact numbers for our USA and German offices, or you can email us at sales@beran.co.uk.